Hey everybody, how are we doing today? So we had finished off last time adding and subtracting polynomials and learning how we classify them by degree and the amount of terms that are in the polynomial. The next given thing is we learn to add, then we learn to subtract. Now we're going to learn to multiply them. And there's a super interesting way to do this. Again, I apologize here. The notes, I must have forgot a y, so we squeezed a little y here in the multiplying polynomials. But we have an interesting way to do this. I mean, they used to do things when I learned in school. It was called the FOIL method, where we were just using like basically a double distribution. We would multiply the first, the outer, the inner, and the last. But that way is not the best way, in my opinion, to stay organized. So what we're doing is we're going to be using the box method. Box method, as long as you do it correctly, it puts everything in perfect order for you, so it makes doing these problems pretty easy. The first thing we have to realize is we have to figure out is what size box do we need? And to do that, we have to look at, well, how many terms are in this first polynomial? And we can see that there are 1, and there are 2, because terms are separated by addition or subtraction. All right, so we have 2. And then we look at this, how many terms are here? Well, yeah, there's 1, and then there's 2 again. So because there's 2 terms in one and 2 terms in the other, we are going to need a 2 by 2 box. As you can see, I drew a box, and I made sure there's 2 on the top and 2 on the side. Now, the last step here in setting up this box is whatever they give you, you have to put on the outside. And we have to be very, very careful. Notice that this one has a -3. So it also has to make sure that that sign comes out here, the -3. All right. Now, if we go through here, and we go through, and now we have to start to fill in this box. So if you look here, look, step number one, fill in this box. Check, we've got that done. Now it says multiply to fill in the box. Well, we multiply vertically and horizontally. And you have to remember that we are going to be using one of our rules from last time. Maybe you remember, oops, it's too big. When we are doing our power rules, right? So our power rule for multiplying, which came from section 7.2, the rule said coefficients get multiplied. Base stays the same. Add the exponent. Of course, I need to move this so that I'm not. So this was our side note here. So this is an important thing here, guys. If we are going to be, we need to make sure we are following this. Sometimes some of our issues that we're having is that we're not remembering our rules. And I told you from day one, algebra is just about following rules. Okay, so here is our rules we have to remember. So now as we start to multiply this, okay, we're going to multiply vertically, horizontally. We have to fill in this first box. Well, look, remember there are invisible powers here. Invisible 1. So we are multiplying 2 like bases together. So that follows this rule here from 7.2. So our base there are no coefficients. The coefficients are 1. So 1 times 1 is 1. Base stays the same. We have to add the exponent. So 1 plus 1 is 2. Notice this box here. Well, all we have is a constant. So a negative 3 times the coefficient, which is 1, is a negative 3. And then the x just comes on over. Same thing here. 1 times 1 is 1, and so the x just comes down. 1 times negative 3, see how we're doing that horizontal and vertical multiplication, is a minus 3. If we've done our work right, we have now filled in all of our boxes, and check, step 2 is finished. Step 3, now that we filled these boxes in, we have to add to get out of these boxes to get our final product. Well, if we've done our job correctly, like terms should add up. And what I mean is, as long as we put our polynomials in standard form across the top and standard form down the side, look at what happens. Our terms diagonally here, they line up. See the diagonal? We have an x, we have an x. We can combine those. So if we're able to combine those, notice how this method sets it up and then puts it in a nice, neat little order for us. We are ready to get our final answer. This x squared, notice, are there any other x squareds in this box? No, so it can just come straight down. Same thing here. This negative 3, notice there are no other just constants in here. So this one can just come on down. Now, all we have to do is the yellow line. We have to combine them. Well, if I have negative 3 of something, and I have 1 of something, so negative 3 plus 1 gives me a negative 2. And what am I adding together? You're adding your x's. So that would give us our final answer here. We have x squared minus 2x minus 3. And you are good to go. Finished our last step. So again, now we have to look at this, and we are looking, we have what, a 2. This has 2 terms. This one has 3 terms. So we set up a box with 2 on one side and 3 across the top. So a 2 by 3. To finish our setup, we have to write our givens. Top, here we go, almost done. 2x, negative 2x. Remember, I carried that negative sign. I carried this negative sign. These are the tricky parts. Now, we have to remember our rule from 7-2. We multiply the coefficients, so 2 times 1 is 2. To multiply the bases, the base will stay the same. We have to add the coefficients. Remember, there is a hidden 1 here, so 1 plus 2 is 3. Fill this one in. 2 times a negative 2 is a negative 4. X times x, remember, hidden 1, base stays the same. Add those exponents. 2 times 1 is 2. And the x just comes over since there is no x on this constant. Negative 3 times 1 is a negative 3. And the x squared comes down. Negative 3 times a negative 2 is a positive 6. And the x comes down. Negative 3 times a positive 1 is a negative 3. I'll show you something. Some of you are still having a problem. So we have Mr. Pizza. All right, here's Mr. Pizza. Notice when you're multiplying negatives and positives, if you multiply 2 negatives together, so if you were to cover these 2 up, right, cover these 2 up, what sign is showing down here? A positive. If you multiply a negative times a positive, so you cover these two up, what's showing your result will be negative. If you multiply a positive times a negative, you can cover these two up. What's left? A negative. So sometimes, guys, this little like pizza or maybe pie slice, whatever you want to call him, he's got his twisted crust going on, can help you remember if you're having a hard time remembering whether you're having these things as being, negative or positive. Just go ahead and draw this real quick. Check yourself. It helps. Now, we filled in all of our boxes. We have to get out of this box. So if we start to take a look at this and we've done our job right, notice these diagonal lines should line up with like terms, right? And they do. The two outer corners, those are the ones that are not like terms. So the only thing we have to do with those is bring them straight down. 2x to the third power minus 3. Now we have to add these, a -3 and a -4. So these are two negative numbers being added together. They become a bigger negative number. So 3 plus 4 is 7, and it's negative. -7 x to the second power. There you go. That wasn't too hard. And then we have a 6 plus 2. Well, that gives us 8. And what are those 8 of? Well, they're 8 x's. And like that, this problem we have just solved using the box method. And it helps us because it lines all of our like terms up, provided that we are putting it in standard form. Now, knowing that, we can actually take it, and that doesn't matter at this point what they give us. Will it be a little bit more multiplication going on? Absolutely. I said, but this organization method really helps us keep everything together. Notice that this has what? 3 terms. This one here has 1, 2, 3, 4. Notice I have made sure I differentiated my negative. So we're going to need a 3 by 4 box. And we'll take and label our box 3x squared. We have a 2x. And we have a 2. And this one here, we have an x to the third. 2x squared. -x. And a 4. And then we have to just start filling these in. So the coefficient here is 3. So 3 times 1 is 3. X to the second times x to the third. Base stays the same. Add the exponents. 2 plus 3 is 5. That's the hardest box we already have filled in. 3 times 2 is 6. X squared times x squared. Base stays the same. Add these exponents. 3 times a -1 is a -3. X to the second times x to the first is x to the third. And 3 times 4 is 12. And then this x to the second comes along. You can also notice, guys, that maybe just look at this box as we've multiplied this down. We go to the 5th power, 4th power, 3rd power, 2nd power. When we keep these in standard form, everything starts to line up and stay the same. Let's do our next row. 2 times 1 is 2. X to the first times x to the third. The base stays the same. We have to add the exponents. So 3 plus 1 is 4. Even this way, let's just do this one here too. 2 times 1 is 2. This carries down. You notice how no matter which way you decide to go, you are staying in standard form that way or this way. Let me hurry up and I'll get some of these done here. We should be pretty good at these by now, since I told you we were going to do that multiplying like bases for like a whole lot in this section. X and X, add it. 1 plus 2 is 3. Negative 2x squared. Because x times x gives you x to the second power, or there's 2 of them. This is an 8x. And then we have a 4x squared. Minus 2x. And an 8. There, step 2 is done. We filled in our boxes. Again, if we've done our job right, these should be x to the fourths, and they are. These, oopsie, these should all line up across here as x to the thirds, and they do. These should all line up here and be x to the second powers. These should all be x's. Notice this nice diagonal pattern. It helps us get it together. And then all we have is, look, these two here, they have nothing in common on the corner, so they rewrite those. 3x to the fifth power. Let's add these. 6 and 2 is a positive 8. Positive 8. X to the fourth. Then we have a 2 and 4 is 6. 6 minus 3 is a positive 3. X to the third. Now we're doing these. I'm going to do some side work out. 12 plus 4 is 16. And then we're going to take away 2. It's 14. Don't be afraid to do side work, guys. Sometimes when we do these things in our heads, we end up making mistakes. You don't want to do this much work and make a careless mistake. Double check your work. And what were those? Those were x squares. Notice our answer is having a lot of terms. And then we have an 8x, and we take away 2 x's, so we have 6 x's. And that lone little 8 just comes down here. Bam! And like that, we have finished what looked to be like it was going to be a lot of work. Really, it was just a lot of little individual multiplication problems, and then a few addition problems. When you keep it in standard form, it lines all these diagonal boxes up perfect. So you have to remember, set up your box. That's step 1. Step 2, we have to fill in the box using multiplication. And then step 3, we have to get out of our box. To leave our box, we add or combine like terms. And if we've done our job right and kept our side pieces when we set up in standard form, everything diagonally should line up for us. And like that, we have learned how to multiply all kinds of polynomials regardless of size. Thanks, guys. I hope you enjoyed the lesson. Now get out there and do your homework.